Hello everyone. Now let's discuss chapter 11, the last chapter of this semester, which is two sample hypothesis tests. So we'll learn already on chapter 10 how to deal with two sample confidence interval. Then now let's look at the hypothesis testing. So basically we're under the same setup, but we also need to consider those 5 steps. So let's look at this example for the two sample case. Actually, this chapter will only have one section. Section 1, 11.1. We want to look at hypothesis test for the difference between two means, and is for independent samples. So it's just matched with what we learned from the previous chapter, chapter 10. So suppose a researcher wishes to determine whether there is a difference in the average age of nursing students who enrolled in a nursing program at a community college and those who enrolled in a nursing program at a university. In this case, the researcher is not interested in the average age of all beginning nursing students. Instead, he's interested in comparing the means of the two groups. His research question is, does the mean age of nursing student who enrolled at a community college differ from the mean age of nursing student who enrolled at a university? Hence, the one population hypothesis will not work anymore. Then we have the following hypothesis. So if mu1 represents one population average, so average age from the community college, and mu2 represent average age from the university, then the alternative hypothesis differ from, so does not equal, they not equal with each other, so mu1 does not equal mu2. That's the claim, the alternative hypothesis. And then the null hypothesis is going to be mu1 equals mu2. So always include a equal sign in the null hypothesis. And as we mentioned, mu1 is the mean age of all beginning nursing students at a community college, mean means average. And mu2 equals mean age of all beginning nursing students at the university. And another way to state the same hypothesis is like this. So h naught, we use mu1 minus mu2 equals 0, and h1, mu1 minus mu2. And then let's change the color, does not equal to 0. So actually, for stating the null and alternative hypothesis for two sample case, the red color is like always. So when you set those up, the null hypothesis is always mu1 minus mu2 equals 0, and the alternative hypothesis is always mu1 minus mu2 what 0. The sign is determined by the question. When you see differ from, then you have not equal, two-sided, and then you can have more than, smaller than, then you need to justify what sign to use. So 3 scenarios. Does not equal, more than, or smaller than, like before. So this is more like the introduction of the two sample case. And then if we compare with the one sample case and two sample case, for one sample we have mu equal a number, and then this sign is to be determined from the problem, more than, smaller than, and then mu what, the same number, right? And for the two samples case, because we want to determine whether the same or not, or increase or decrease, then the only thing we need to justify is the sign from the alternative, and then the other setup will remain same for all different cases. Then let's look at another example. Conroe High School student ACT score with that of Huntsville High School students. So if this represents population 1, and then we have to collect sample from the two different populations. So we have sample 1 and sample 2. So that we have x1 bar, the sample mean from this sample from population 1. And then we have x2 bar from this sample from population 2. And then if we want to compare whether mu1 and mu2 is the same, then we have mu1 minus mu2 as the difference, right? And then the point estimate will be x1 bar minus x2 bar, just the sample mean difference. So population mean difference is what we're interested in, and then we use the point estimate, the sample mean difference, to represent the population mean difference. And then now we actually want to look at the sampling distribution for this mean. So what distribution is it follows? Distribution. So since we learned actually the one sample case, so most likely if we know the population standard deviation, then we have a normal distribution. If we don't know the population standard deviation, then we have a t distribution. So now the question will be testing difference between two means using the z-test, which is population standard deviation known, and also another scenario is testing the difference between two means using the t-test. That's when population standard deviation unknown. So now let's look at some assumptions for this first scenario, z-test. So if we want a z-test, that means we want to make sure the sampling distribution for x1 bar minus x bar follows a normal distribution. Then the assumptions we have to meet will be both samples are random samples, and then the sample must be independent of each other, and the standard deviation of both population must be known. So population known, that means sigma 1, sigma 2 known. And we either have a large sample size, or we need the sample size. We need to have a normal distribution if the sample size is small. So that is actually from the CLT, central limit theorem. And then we have to mention this, the formula. That is actually the test statistics. Test statistic will be again same, very similar to the one sample case. So we have x bar minus mu naught over s over sigma over square root of n as the one sample. This is one sample case. And then two sample, the test statistic change to this form. And it's very similar to the one sample. And let's see why it is like that. So to get the sampling distribution for x1 bar minus x2 bar, we have to know the mean. So the mean will be just the original mu1 minus mu2. And then we need to know the variance for x1 bar minus x2 bar. Actually, if you look at the variance of x1 bar minus x2 bar, that's the sum of the individual variance. So what is sigma squared x1 bar? Then that is sigma 1 squared over n1 by the sampling distribution's variance. So we have this two specified. And then take sum. That's the variance for x1 bar minus x2 bar. So that's going to be sigma 1 squared over n1 plus sigma 2 squared over n2. And then that's a variance. Then standard deviation will be square root of the variance, so of this format. So we basically know the standard deviation and mean for this sampling distribution. Then test value or test statistic always equals the standard score, right? Standard to score is the observed value minus expected value divided by standard error. So if we look at the one sample case, we have x bar minus mu naught divided by square root of the variance. Variance is sigma squared over n. Then using the same format, now we're using the two sample information. X bar, that's x1 bar minus x2 bar. X bar minus mu1 minus mu2 divided by square root of the variance. That's the standard deviation. So we rewrite it. So this z score, the standard score, is actually our test statistics. Now let's stating the hypothesis. So how many ways we have for this alternative hypothesis for comparing two means? We actually again have three cases. We have two-tailed, right-tailed, and left-tailed. So for two-tailed, we have does not equal sign. For right-tailed, we have more than here. That's the more than. And then for left-tailed, we have smaller than. So which form you want to use is all okay, but I think this is easier to remember, the second format. Then now all we need to do is follow the one sample procedure, 5 steps, and then complete the hypothesis test. Let's now look at an example. Suppose someone claims that Conroe students score higher, Conroe students score higher on their ACT than Hartsville students. A sample of 35 Conroe students is taken with a mean of 23.7. So 35, 20, 3.7, and then population standard deviation 6.2, and 32 for Huntsville, and then 22.2, 4.5 for standard deviation, and then the alpha equals 0.01. Score higher, so we also want to circle that. That's the claim to tell us what sign we want to use for the alternative hypothesis. So now let's look at our 5 steps. So step 1, we want to state the null and alternative hypothesis. So before that, we can just gather some information from the question. So for Conroe students, so the population mean is mu1, and the sample information we have is here. X1 bar 23.7 and 135, and population variance is 6.2 squared, because standard deviation is 6.2. So sigma 1 squared, that's 6.2 squared. And same thing for mu2, the second population. And now we want to state the null and alternative hypothesis. Mu1 minus mu2 equals 0. That is, like always, no matter for which question, you're going to write down that for the null hypothesis. And the alternative hypothesis equals mu1 minus mu2, what sign, and then put a 0 there. So Conroe scores higher. Mu1 stands for Conroe, right? Scored higher, that means more than 0. So that is from the term higher. And then that's the claim. That's the claim. Second step, we want to state the critical value. So for critical value, we need to put alpha value here, 0.01 given from the problem. And then the second information we need to know is what sign we have from the alternative hypothesis, more than sign. And that tells us this is one-tailed right. One-tailed right test. Then we can draw this little normal curve here. So 0 in the center. So right-tailed, right? One-tailed right. That means the rejection area from the right end. And then what is this area? That's alpha, which is 0.01. So how to express some value to the right? You have 1%. So then this number is going to be z sub alpha, which is z sub 0.01. And then it's definitely a positive number because it's on the right of 0, so that means more than 0. So then this value we can check from the standard normal table. So 0.01, from the standard normal table, we're going to check the opposite, which is 0.01, which is 0.99. So 0.9900, we have it in between of these two values. So we read 2.32 and 2.33. So 2.325 will be the best guess we can have for this critical value. So we say 2.325. That is the critical value here. And for one tail, we have one critical value. For two tail, we then have two critical values. So it's determined by what sign you have for the alternative hypothesis. And then for test statistic, is x1 bar minus x2 bar. Actually, we have minus mu1 minus mu2 in the original formula, right? The standard score. But whether you put it here, it doesn't really matter, because when we assume null hypothesis is true, so this goes to 0. So that's going to be 23.7 minus 22.2 minus 0. So whether you put it here doesn't really matter. But we need to know this test statistic is the evidence, which we circled here, combined with the assumption that the null is true. And then calculate that out, we got 1.1401. And then step 4, let's make decision. So when we make decision, we want to look at whether this value is in the n-euro area. So go back to the curve you draw, put 1.14 there. So this is 2.325. So 1.14 is actually here. So that number doesn't lie within this rejection region. So we don't reject that. We say we fail to reject it. So that's actually 1.1404 is not more extreme compared to the critical value. So we fail to reject the null hypothesis H naught. And conclusion is always in terms of H1. And then we say in conclusion there is not enough, because we fail to reject H naught, so we kind of in favor of H naught. So there's not enough evidence to conclude the claim. The claim is what? Conroe student score ACT on average higher than Huntsville student at alpha. So same as before, don't forget the significance level alpha. So that's the complete 5 steps for this question. And then we can look at another practice problem. Okay, let's record another video for this practice problem. For this one, let's stop here. Thank you.